Assalamualaikum and hi everyone. Today I'm going to solve question 1, which is explain the meaning of differentiation and what are the techniques of differentiation. So firstly, what is differentiation? Differentiation is the process of finding the rate of change of a function. It is the rules and steps we follow to calculate how a function changes at any given point. So we have two different terms, which is differentiation and derivative. And what is derivative? Derivative represents the rate at which the function's output changes concerning its input. The derivative of a function fx at a point x is defined as f prime x equals to limitation h equal to 0 with fx plus h minus fx over h. From this formula, or we call limits, if it is axis, it gives the slope of the tangent line to the function at the point x. So in an easy word, differentiation is a process of finding the rate of change of a function, while the derivative is represented as the rate of function itself. Next, we are going to take a look at the techniques of differentiations. So firstly, we have a chain rule. What is chain rule? Chain rule is a composite function where they have function inside another function. Use this formula whenever we come across a chain rule questions. The second one, we have quotient rule. Quotient rule is where we let y equal to u over v. So this is basically a rational function where numerator we put it as u and the denominator we put it as v. The third one, we have product rule. Product rule is a bit similar with quotient rule. Chain rule we use when it's a rational function, but product rule we use when it comes to multiplying. So we let y equal to uv, where u and v are two differentiable functions. Next one, we have sum and difference rule. So differentiation distributes over addition and subtraction. The next one, we have power rule. Power rule applies when n is a real number. So basically, when there is in the question, they have function, and in the function we have power, which the power is a real number. So we use power rule to solve the question. The next one, we have constant rule. Constant rule is where the derivative of a constant is always 0. Last but not least, we have constant multiple rule. It can be pulled outside the derivative. So in this topic, we have 7 different techniques of differentiations.
We're moving to question 2e, is we need to find the differentiation y equal to 3x squared secant x plus 2 with respect to x. This function is a product of two parts, which is first part will be 3x squared and the second part is secant x plus 2. Since we are multiplying two expressions, we need to use the product rule. Well, the product rule says that dy dx equal to uv prime plus vu prime. This will be the formula that we are using in this question. Let's say that 3x squared is u and secant x plus 2 is v. So we're going to the first step, which is we need to differentiate each part separately. It is highly recommended for you to write the information given so there will be no confusion. Right, so firstly, we will differentiate u equal to 3x squared. Derivative of u is u prime equal to 6x. We will differentiate v equal to secant x plus 2. As we know, secant x plus 2 is the function of trigonometrics. So this is required chain rule. We know the derivative of secant x is equal to secant x tangent x. For this question, you can just substitute x plus 2 to the formula. So this is the derivative of secant x plus 2. For step 2, the information that we'll extract need to substitute them into the formula of product rule. After we substitute, this is the answer that we will get. This will be our u, this will be our v prime, plus with v and u prime. This is not yet to be our final answer, since we notice that we have secant x plus 2 in both terms. In step 3, we are going to simplify this by factorize secant x plus 2. So the final answer will be dy dx equal to secant x plus 2 6x plus 3x squared tangent x plus 2. And this will be our final answer for this question.
Today I will now explain the solution to the differentiation of y equals to 4x plus 2 over cosine x. And first, I will recognize that this is a fraction of two functions, so I will apply the quotient rule first. The quotient rule states that dy by dx is equal to v times u prime minus u times v prime over v squared. So first I will let u equals to 4x plus 2 and v equals to cosine x. And then I will differentiate both. U prime equals to 4 and v prime equals to negative sine x. And now I will substitute all of that into the formula dy by dx is equal to open bracket cosine x times 4 close bracket minus with open bracket 4x plus 2 close bracket and times with negative sign x all over cosine square x. Next, I will expand and simplify the numerator. 4 times cosine x is 4 cosine x. Then negative times negative give us positive. So I will expand open bracket 4x plus 2 close bracket times sin x to get 4x sin x plus 2 sin x. That give me dy dx is 4 cosine x plus 4x sin x plus with 2 sin x over cosine squared x. And then I will arrange the terms in the numerator as 4x sin x plus 2 sin x plus 4 cosine x over cosine squared x. And then I will factor the sine terms as open bracket 4x plus 2 close bracket and sin x plus 4 cosine x. And I will simplify further using the trigonometric identities. I will use the identity tangent x equals sin x over cosine x and the secant x equals 1 over cosine x. So the full expression becomes dy by dx is equal to open bracket 4x plus 2 close bracket times tangent x times with secant x and plus 4 secant x. And this is the final simplified derivative I get. This method works by expanding directly after applying the quotient rule and makes the use of the basic trigonometric identities. It is clear and effective way to solve this type of problem without overcomplicating the process.
Assalamualaikum everyone. I'm going to explain to you the solution for question 3, which is using implicit differentiation. So the question is, given y ln 3x minus e power of 2x plus 1 minus tan 4y equal to 0. Find dy dx using implicit differentiation. So the equation for this question is y ln 3x minus e power of 2x plus 1 minus tan 4y equal to 0. First, we differentiate the question with respect to x. So the question become e over dx in bracket y ln 3x minus d over dx in bracket e power of 2x plus 1 minus d over dx in bracket tan 4y equal to 0. Okay, after that, we will differentiate first term, which is d over dx in bracket y ln 3x using product rule. So the equation for product rule is vu prime plus uv prime. So for u in this term is y, while for u prime is dy dx. For v is ln 3x and for v prime is 1 over 3x and we times with 3 and we get 1 over x. So we put all the derivative in the equation, which is vu prime plus uv prime, and we get the dy over dx times with ln 3x plus y times with 1 over x. For second term, that is d over dx in bracket e 2x plus 1, we will use chain rule and we will times with 2 and we get 2e power of 2x plus 1. Third term, which is d over dx tan 4y, we also use the chain rule and we will change the tan to secant square. So secant square will times with 4y and times with d over dx 4y, and we get the answer for secant square 4y times with dy dx. Then we will substitute back all the derivative into the original equation. So we get dy over dx times with ln 3x plus y times with 1 over x minus 2e power of 2x plus 1 minus 4 secant square 4y times with dy dx equal to 0. And we will move and put all the dy dx on the left side and non-dy dx to the right side. So we get ln in bracket 3x minus 4 secant square 4y times with d over dx equal to 2e power of 2x plus 1 minus with y over x. We only want the dy dx, so the answer is 2e power of 2x plus 1 minus v over x over and we divide with ln 3x minus 4 secant square.
Assalamualaikum warahmatullahi wabarakatuh. So today I will explain how to solve its linear approximation. Okay, now we're gonna go through the question. So the question asks to use linear approximation to estimate the value of 4 square root of 80.99 minus 2 over square root 80.99. Its final answer will be in 3 decimal places. Okay, so first we have to do is define the function. So 80.99 we can write it as x. So the function of x is actually 4 square root of x minus 2 over square root x. To make it easy for the next step, I write it back as x power of 1 over 4 minus 2x power of negative 1 over 2. Okay, the second step is to do a differentiation to find f prime. So f prime is equal to 1 over 4 x power of negative 3 over 4 minus x power of negative 3 over 2. Okay, the third step is to find what is the difference between given value and the initial value. So we have to do is given value minus initial value. The initial value must be close to the given value and it will be in a whole number. So I choose 81. So 80.99 minus 81 will be negative 0.01 for the differential. Okay, now all the value will be substituted back in the formula fx plus f prime times the difference of the given and the initial value. So we will get 2.77769893. So we go back to the question. It's it has 3 decimal places. So the final answer will be 2.777. So as you can see, if we put it in the calculator, we solve it by the calculator, will have the same answer, or it's very close.
So, in conclusion, the techniques of differentiations are fundamental tools in calculus, allowing us to find the rate of change of functions. Among the core techniques are the power rule, product rule, chain rule, and the quotient rule, which serves a specific purpose when dealing with different types of the functions. That's all from us.